FCU, Fan Coil Unit. A fan coil unit, FCU, is a type of air handling unit that is used in air conditioning systems. It consists of a fan, a heating or cooling coil, and a filter. The FCU is typically located inside a building and is connected to an outdoor unit such as a condensing unit, CU. The function of an FCU is to circulate air through the heating or cooling coil and distribute it throughout the building. The air is drawn in through the filter and passed over the coil, which either heats or cools the air, depending on the requirements of the building. The fan then blows the conditioned air back into the building through ductwork or vents. For example, in a central air conditioning system for a multi-story office building, each floor may have several FCUs that are connected to a centralized chiller plant. The FCUs on each floor will draw in air from the building and pass it over a coil that either heats or cools the air. The conditioned air is then distributed throughout the floor through ductwork or vents. CU, condensing unit. A condensing unit, CU, is an outdoor component of an air conditioning system. It consists of a compressor, a condenser coil, and a fan. The CU is responsible for compressing and circulating the refrigerant gas through the system. The function of a CU is to compress and circulate the refrigerant gas through the system. The refrigerant gas is compressed by the compressor and then circulated through the condenser coil, which is located in the outdoor unit. The fan blows air over the condenser coil, which removes heat from the refrigerant gas, causing it to condense back into a liquid. The liquid refrigerant then flows through the refrigerant pipes to the indoor unit, where it passes through the evaporator coil, and the process of cooling or heating the air begins. For example, in a split air conditioning system for a residential home, the CU is typically located outside the home, and it is connected to an indoor unit through refrigerant pipes. The indoor unit is typically an FCU or an air handling unit, which is responsible for distributing the conditioned air throughout the home. The CU compresses and circulates the refrigerant gas, which passes through the indoor unit's evaporator coil, and then returns to the CU to repeat the cycle. The compressor is a mechanical device that is used in air conditioning systems to compress and circulate refrigerant gas through the system. The compressor is responsible for increasing the pressure and temperature of the refrigerant gas, which allows it to absorb heat from the indoor air and release it outside. For example, in a central air conditioning system for a large commercial building, the compressor may be located in an outdoor unit, and it is responsible for compressing the refrigerant gas and circulating it through a network of indoor fan coil units or air handling units. As the refrigerant gas passes through the coils, it absorbs heat from the indoor air and then releases it outside. Refrigerant gas is a substance that is used in air conditioning systems to absorb heat from the indoor air and release it outside. Refrigerant gas circulates through the system in a closed loop and undergoes phase changes to absorb and release heat. For example, in a split air conditioning system for a residential home, the refrigerant gas may be R410A, which is a type of hydrofluorocarbon, HFC, that is commonly used in air conditioning systems. The refrigerant gas is compressed by the compressor and then circulated through a network of indoor and outdoor coils, where it absorbs heat from the indoor air and releases it outside. Refrigerant pipes are used to transport refrigerant gas from the outdoor unit to the indoor unit and back again. The refrigerant pipes are typically made of copper and are insulated to prevent energy loss. For example, in a ductless mini-split air conditioning system, the refrigerant pipes are used to connect the outdoor unit to one or more indoor air handling units. The refrigerant gas is compressed by the outdoor unit's compressor and then circulates through the refrigerant pipes to the indoor units, where it passes through the evaporator coil and cools the indoor air. Liquid refrigerant is formed when the refrigerant gas is cooled and condensed by passing through the outdoor or indoor coils. The liquid refrigerant then flows through the refrigerant pipes to the indoor unit, where it passes through the evaporator coil and absorbs heat from the indoor air. For example, in a central air conditioning system, the liquid refrigerant may flow through a network of pipes to multiple indoor air handling units. As the liquid refrigerant passes through the evaporator coils in the indoor units, it absorbs heat from the indoor air and then returns to the outdoor unit to repeat the cycle. Variable speed fans are fans that can adjust their speed to match the cooling needs of the room. They can operate at lower speeds when less cooling is needed, which can save energy and reduce noise. Variable speed fans are often used in air handling units or fan coil units in air conditioning systems. For example, in a commercial building, an air handling unit may contain a variable speed fan that adjusts its speed based on the cooling needs of the room. As the temperature in the room changes, the fan will adjust its speed to provide more or less cooling as needed. Programmable thermostats are devices that allow users to set a schedule for their air conditioning system to turn on and off at specific times. This can help save energy and reduce costs by ensuring that the system is only running when it is needed. For example, in a residential home, a programmable thermostat may be used to set the air conditioning system to turn on at a specific time in the evening when the occupants are home, and turn off during the day when the home is empty. Air purifiers are devices that are designed to remove impurities, allergens, and other particles from the air in a room. They work by using filters or other technologies to capture and remove these particles from the air. For example, in a residential home, an air purifier may be used in conjunction with an air conditioning system to improve indoor air quality. The air purifier may use HEPA filters to capture allergens and other particles from the air, while the air conditioning system helps to circulate and cool the air. Overall, these components are essential for the proper functioning of an air conditioning system. The compressor and refrigerant gas work together to absorb heat from the indoor air and release it outside, while the refrigerant pipe and liquid refrigerant transport the refrigerant gas throughout the system. Variable speed fans and programmable thermostats help to improve energy efficiency and reduce costs, and air purifiers can help improve indoor air quality.